far above the quiet surface of Earth, small grains of dust move slowly through the darkness of space. Tonight, there is nothing to solve and nowhere to hurry. This is a calm journey through soft scientific ideas, gentle observations, and the hidden movement of cosmic dust drifting through the universe. A single grain of cosmic dust can travel for millions of years before touching anything at all. Some of these particles are smaller than smoke, and many are older than Earth itself. They float between stars in wide and silent clouds, moving through space with almost no resistance. The universe is filled with quiet material that often goes unseen. Much of it exists in forms too small for the eye to notice. Cosmic dust is one of those forms. It gathers slowly around stars, drifts across galaxies, and settles into long ribbons that stretch through empty regions of space. Even in areas that appear completely dark, there are usually tiny particles moving gently through the cold. For the next little while, the pace will remain slow and steady. The facts will move softly from one idea to another, like distant objects crossing a night sky. There is no need to focus closely. The mind can drift as easily as the dust itself. Many people imagine space as completely empty, but the universe contains a surprising amount of fine material. Tiny grains of carbon, silicon, iron, and frozen ice float between stars. Some dust particles are shaped like rough crystals. Others are thin and uneven, formed slowly by heat and pressure around ancient stars. A large amount of cosmic dust begins near dying stars. When stars grow old, they release material into space. Their outer layers drift outward in expanding shells. Over time, cooling gases condense into solid particles. These particles become dust grains that move away from the star and into the larger galaxy. Some of the dust around the universe comes from exploding stars called supernovas. During these massive explosions, heavy elements are scattered outward at enormous speeds. As the material cools, tiny solid particles begin to form. Long after the bright flash of the explosion disappears, the dust continues drifting quietly through space. The dust between stars is often called interstellar dust. It exists inside wide regions known as nebulae. These nebulae can stretch across many light years and contain gas, ice, and microscopic particles floating together in slow motion. Under the right conditions, gravity gently pulls some of this material into denser clouds. Inside these cold clouds, stars can begin forming. Tiny particles of dust help the process happen. The grains provide surfaces where atoms can gather together. In some regions, frozen layers of water, methane, and ammonia collect on the outside of dust particles. Over long periods of time, more material gathers nearby. Eventually, gravity causes sections of the cloud to contract inward. The center becomes warmer and denser. Slowly, a young star begins to appear. Around it, the remaining dust forms a spinning disk. Inside these disks, grains collide softly and stick together. The process is extremely gradual. Dust grains become pebbles. Pebbles become rocks. Rocks combine into larger bodies. Across millions of years, planets slowly emerge from clouds of fine material surrounding newborn stars. Earth itself formed from cosmic dust billions of years ago. Long before oceans or mountains existed, the young solar system contained countless drifting particles orbiting the sun. Through endless collisions and gathering, these particles became larger structures. Eventually, they formed planets, moons, asteroids, and comets. Some cosmic dust still falls onto Earth today. Every day, tiny particles from space enter the atmosphere. Most are extremely small, often no larger than grains of sand. As they drift downward, they burn gently from friction with the air. Some settle quietly onto oceans, deserts, forests, and cities without ever being noticed. Scientists estimate that thousands of tons of cosmic dust reach Earth each year. Much of it comes from comets and asteroids moving through the solar system. Small fragments break away and continue orbiting the sun. When Earth passes through these trails, some particles enter the atmosphere. Meteor showers happen because of these streams of dust. As Earth moves through a comet's old path, tiny grains strike the upper atmosphere at high speeds. The particles heat the air around them, producing brief lines of light across the night sky. Most of these grains are smaller than pebbles, yet they create visible streaks overhead. In deep space, dust often behaves in delicate ways because there is very little air or pressure. Sunlight itself can slowly push dust particles across space. This effect is called radiation pressure. Even though light has no weight, it still carries momentum. Over enormous periods of time, light can gently influence the movement of tiny grains. Magnetic fields also shape the paths of cosmic dust. Many particles contain metals or electric charges. As they move through magnetic regions around stars and planets, their motion can shift slowly. Invisible fields guide some particles into long curves and streams. The rings of planets contain large amounts of dust. Around Saturn, countless icy particles orbit together in thin layers. Some are tiny as powder, while others are much larger. The rings appear bright because sunlight reflects from the icy surfaces of these drifting grains. Even Earth's moon contains dust, unlike dust found on Earth. Lunar dust is sharp and dry because there is no wind or rain to smooth the particles over time. The fine material clings easily to surfaces due to static electricity. During the Apollo missions, astronauts noticed that lunar dust stuck to boots, gloves, and equipment in stubborn layers. On Mars, dust storms can grow across entire regions of the planet. Fine reddish particles rise into the thin atmosphere and remain suspended for long periods. Some storms become so large that they cover nearly the whole planet. The sunlight grows dim behind the drifting clouds of dust. The color of cosmic dust depends on what it contains and how it reflects light. Carbon-rich dust often appears dark and smoky. Dust containing ice can reflect pale blue or white light. Some nebulae glow red because nearby stars energize surrounding gases mixed with dust particles. Many famous images from telescopes show enormous clouds of dust crossing space like soft rivers. In visible light, these clouds can appear dark because the dust blocks light from stars behind them. In infrared light, however, telescopes can sometimes see through the dust and observe hidden regions inside. Without cosmic dust, the universe would look very different. Dust helps cool large clouds of gas, making star formation possible. It carries heavy elements across galaxies. It provides material for planets and moons. Even living things on Earth are connected to ancient dust formed around long-dead stars. Atoms of carbon inside the human body were once part of distant stars. Long ago, those atoms drifted outward into space, mixed with dust clouds, and later became part of new worlds. Over billions of years, the material recycled through stars, planets, oceans, and life itself. The movement of dust across the universe is usually silent and slow. In many regions, particles travel for centuries without touching anything larger than another grain. Space is vast enough that even crowded clouds remain mostly empty. Some dust particles spend millions of years exposed to cosmic radiation. Tiny impacts and energetic particles slowly change their surfaces. Scientists study these grains carefully because they contain clues about the early universe and the origins of solar systems. In laboratories on Earth, researchers sometimes examine microscopic dust collected from space missions. Certain grains trapped inside meteorites are older than the sun itself. These ancient particles formed around stars that existed before the solar system was born. Their chemical structures preserve traces of environments from unimaginably distant times. Cosmic dust may appear unimportant because of its small size, yet entire planets can emerge from it. Wide galaxies glow partly because of it. New stars begin inside clouds shaped by it. Across the universe, fine drifting particles quietly influence the structure of space itself. The darkness between stars is never completely empty. Thin layers of matter continue moving gently through the cold, carrying traces of ancient explosions, vanished stars, and future worlds not yet formed. Somewhere in the quiet distance, another small grain of dust drifts slowly across the endless night. Far from the bright center of most galaxies, thin clouds of dust continue drifting through regions so quiet that a single collision between particles may take years or even centuries to occur. The universe operates patiently on scales far beyond ordinary experience. In these distant areas, tiny grains float through darkness with no sound and almost no interruption. Inside the Milky Way, large lanes of dust stretch between the spiral arms of the galaxy. From Earth, some of these regions appear as dark ribbons crossing the night sky. The dust blocks portions of starlight, creating soft shadows against the brighter background of distant stars. Ancient observers looking upward could not see individual dust grains, but they still noticed the dark bands scattered through the Milky Way. Before modern telescopes existed, many people believed these areas were simply empty spaces without stars. Later observations revealed that the darkness came from clouds of material absorbing and scattering light. Dust changes the appearance of the universe in gentle ways. Blue light scatters more easily than red light when passing through fine particles. Because of this effect, distant stars sometimes appear redder than they truly are. Astronomers use these changes in color to estimate how much dust exists between Earth and faraway objects. The study of cosmic dust became more detailed during the 20th century. Improved telescopes allowed scientists to observe invisible wavelengths of light beyond normal human vision. Infrared instruments became especially useful because infrared light can travel through many dusty regions that block visible light. Infrared telescopes revealed hidden stars forming deep inside dark nebulae. Areas that once looked empty or opaque suddenly appeared full of structure and motion. Young stars glowed softly within clouds of dust, surrounded by spinning disks of material that might one day become planets. Some dust clouds in space are enormous. Certain nebulae stretch across dozens or even hundreds of light years. Despite their size, the material inside them remains extremely thin. A cloud larger than many solar systems combined may still contain less matter overall than Earth's atmosphere. The famous pillars of creation inside the Eagle Nebula are formed partly from dense columns of gas and dust. These towering structures rise through surrounding space like silent mountains. Inside them, new stars slowly form as gravity gathers material inward over long periods of time. Cosmic dust also exists between galaxies. The space separating galaxies appears mostly empty, yet traces of matter drift there as well. Tiny particles move slowly through intergalactic space, carried outward by explosions, radiation, and galactic winds generated by star formation. Some galaxies contain especially large amounts of dust. Spiral galaxies often hold rich clouds of gas and fine particles because stars continue forming inside them. Elliptical galaxies usually contain less visible dust because they have lower rates of new star formation. In certain galaxies, dust lanes create dramatic patterns around bright centers. These shapes appear smooth and curved when viewed through telescopes. Some resemble flowing smoke suspended in still water. Others form rings or wide arcs crossing entire galactic structures. Dust affects temperature throughout the universe. Tiny grains absorb energy from nearby stars and later release it as infrared radiation. This process helps regulate conditions inside clouds where stars are born. Without dust cooling these regions, star formation would happen differently. Even very cold dust still emits faint energy. Some particles drifting in deep space are only a few degrees warmer than absolute zero. Yet, sensitive instruments can still detect the weak infrared glow produced by these grains. The James Webb Space Telescope observes many dusty regions using infrared light. Its instruments can study areas hidden behind thick clouds that older visible light telescopes could not fully examine. These observations help scientists learn more about the earliest galaxies and the formation of ancient stars. Dust played an important role in the early universe. Shortly after the first stars formed, heavy elements began spreading outward through stellar explosions. Over time, these elements cooled into microscopic particles. Slowly, the universe gained more dust as generations of stars lived and died. The earliest galaxies may have changed rapidly once dust appeared in larger amounts. Dust influenced how gas cooled, how stars formed, and how light traveled through space. Even today, astronomers continue studying how quickly dust emerged after the beginning of the universe. Some cosmic dust grains are surprisingly complex. Laboratory analysis shows that certain particles contain long chains of carbon molecules. A few resemble materials connected to organic chemistry on Earth. Scientists continue examining whether these compounds played any role in the early chemistry that eventually supported life. Tiny grains collected from meteorites sometimes contain isotopes, unlike those commonly found on Earth. These unusual patterns reveal that the particles formed around specific kinds of stars long ago. In this way, single microscopic grains can preserve records of ancient stellar environments. Space missions have gathered dust directly from comets. One example was the Stardust mission, which collected particles from Comet Wild 2 and returned them to Earth for study. Researchers discovered minerals that likely formed near the young sun before later traveling outward into colder regions where comets developed. This suggested that material in the early solar system mixed together across surprisingly large distances. Dust grains may have traveled from hot inner regions to distant icy areas over time, carried by turbulent motion inside the solar nebula surrounding the young sun. Comets themselves contain large amounts of dust mixed with frozen gases. As a comet approaches the sun, heat causes ice inside the comet to vaporize. Escaping gas carries dust outward, creating the glowing tails visible from Earth. Some tails stretch millions of kilometers through space. The dust tail of a comet curves gently because sunlight and solar wind push the particles away from the sun. Larger grains move differently from smaller ones, causing delicate patterns to form within the tail. Certain meteor showers return at predictable times each year because Earth repeatedly passes through old dust trails left behind by comets. The Perseids, Leonids, and Orionids all come from streams of tiny particles orbiting the sun. Some of the smallest dust particles entering Earth's atmosphere settle slowly through the air and eventually reach the ground or oceans. Scientists have collected micrometeorites from rooftops, polar ice, and deep-sea sediments. Many are nearly invisible without magnification. In Antarctica, researchers search for preserved cosmic dust trapped inside ancient ice. The cold environment helps protect delicate particles from contamination. Each tiny grain carries information about processes occurring elsewhere in the solar system. Dust also exists around black holes. In active galaxies, enormous clouds of gas and dust can orbit supermassive black holes at galactic centers. Some of this material forms thick structures called dusty tori. These regions partially block intense radiation coming from the area near the black hole. The interaction between light and dust creates many beautiful astronomical effects. Reflection, nebulae shine because nearby starlight scatters from dust particles. Emission, nebulae glow when energetic radiation excites surrounding gases mixed with dust. Dark nebulae appear as shadows where dense material blocks light behind them. The Horsehead Nebula is one example of a dark nebula. Its shape appears sharply outlined against a glowing background of gas. Though it looks solid from far away, it is actually a cloud of thin material spread across many trillions of kilometers. Dust particles themselves are often irregular rather than smooth. Under magnification, some resemble tiny broken stones or uneven crystals. Their shapes influence how they absorb and scatter light across space. In protoplanetary disks around young stars, dust grains sometimes collide gently enough to stick together. Electrostatic forces help tiny particles cling to one another at first. Over time, larger structures begin forming through repeated collisions. Scientists still study how small grains eventually become planets. The process remains difficult to model completely because conditions inside young disks are extremely complex. Even so, observations show clear signs that dust slowly gathers into larger objects around developing stars. Some young stars are surrounded by thick, dusty disks with gaps and rings already visible. These patterns may indicate that forming planets are clearing paths through the material as they orbit. Across the universe, dust continues cycling through generations of stars. A grain may begin near one dying star, drift through space for millions of years, become part of a new solar system, and eventually join a planet or moon. The process moves slowly enough that entire civilizations would rise and disappear, while a single particle continued its quiet journey. The night sky seen from Earth contains many traces of cosmic dust, even when it goes unnoticed. Soft glows between stars, faint zodiacal light before sunrise, and distant nebulae all depend partly on fine particles floating through space. Before dawn in very dark locations, a pale triangular glow sometimes appears along the horizon. This light comes from sunlight reflecting off dust scattered through the inner solar system. The effect is called zodiacal light, and it is caused by countless small particles orbiting the sun together. Even the calm darkness of space contains movement almost everywhere. Dust drifts between planets, across galaxies, and through enormous interstellar clouds, continuing its slow passage through the universe without sound or urgency.